So I'm Ahmed El-Helw.
And I'm Oubai Abbasi.
And we're both engineers at Careem working on mobile, on Android.
Alright, so let me start by introducing our talk. So CI usually stands for continuous integration. And by having CI in your organizations, that leads to continuous improvement in your code bases and applications. So if I might step back and explain what CI actually means in a couple of words, when you have new code being introduced to your existing code base, CI is the process that ensures this newly introduced code is up to the standards, code style checks, and quality, as well as it helps you prevent some common bugs and issues in your code. So if we start talking about starting a project, so when you start working on any application or project, you can pretty much know the whole project. If it's a weekend thing, you can know the code A to Z, you're more familiar with it, it's all fresh in your mind, and that's perfect. But once you continue working for months or years on a project, or you have multiple people collaborating on this code base, then you start running into some issues. So issues like, how do we make sure that whenever we provide a build that's actually stable, how can we trust that? Things like, how can we maintain our code quality and code standards while the team is growing and make sure it's enforced? How can we quickly find possible bugs before they make their way into production and our code base? And how can we make our builds available more widely and quickly to QA, our colleagues in the organization, or customers? And finally, how can we uncover some hidden changes that even with your regular code reviews, people tend to miss because they're hidden? All right. So, why should we implement CI? It's very simply, you can say that it allows you to ensure your code style, that is consistent across your code base. You can catch common bugs and design flows, encourage a test-driven culture within your organization or team, and build trust in your code quality and the build that you provide to your team. There are a lot of tools that implement CI, and we're not here today to talk about any specific tool because there are a lot of tools like Jenkins, Betry, Circle, CI, and Travis that do great jobs, and there are even more great tools. But what we will talk about today is all the different steps that you can introduce into your CI in order to make sure that it works and it gives you the best results possible.
So one of the steps from this pipeline that Oubai mentioned is static analysis tools. Static analysis tools are tools that actually look at your code and try to identify bugs early on in cases where a human review might miss it. Of course, it's always good practice for us to practice code reviewing, but a lot of times some of these issues can range in their severity from being super subtle to actually things that are actually that we might just not know at the time. So one such tool is Check-Startup. To quote them, it's a development tool to help programmers write Java code that adheres to a coding standard. It automates the process of checking Java code to spare humans of this boring but important task, and makes it ideal basically for enforcing coding standards. So let's take an example. So here's a really simple class with a really simple method that just has two numbers. Does anyone see anything wrong with this? It's actually a trick question, but if we run it through check style, it'll say line contains the task character. But how would you know that while you're reviewing the code, right? And line you never use space. Another example, again, super subtle, but right after the there's an extra space before the T, and again, check style will catch it, right? And then a third example, again, it's hard to see, you have to like strain your eyes, but right after awesome, there's a space missing, right? And so, in addition to these, check style does additional checks, but really the main thing is, imagine your coworker sends you a code review, and it's 200 lines. do you really want to be that person who's commenting on every line, like, hey, you missed a space here, hey, please do this? You don't want to be that person, right? You want to focus on telling them about the actual logic, so that, you know, if there are bugs in the logic, you review these bugs and you help identify them early on. But yeah, going back to check style, it identifies other stylistic issues. For example, if you do an import with star in the package, you shouldn't do that. The order of imports, some people like, you know, does packages come before org and so on and so forth. The modifier orders are public fields before private fields are protected, like what order you do them in, adding unnecessary parentheses and so on. It also tries to catch some code smells and issues with design in your methods or classes. So let's give some examples. So here's an example where we're just multiplying the value by 2. There's nothing like really wrong with this method, but check style will tell us assigning a parameter value is not allowed. So there's really no reason for us to be assigning one of the input parameters to another value. And as a matter of fact, if you think about it, for those of us who started using Kotlin, that's why by default, parameters in Kotlin method calls are values by default. Here's another example. So I have some code that's taking a number, it's not modifying it after, whereas the second variable, it is modifying it after. So again, nothing fundamentally wrong with this code. But then, you know, check style will say variable fantasy should be declared final because, you know, Final Fantasy. So then another example, let's say I have a util class. So I have 2 operations, 2 static methods, op and second op. And again, nothing fundamentally wrong with this code. But check style will say, hey, someone could actually come and instantiate this, and you probably don't want that to happen. So utility classes should not have a public or default constructor, right? And so on. So I want to shift gears to talk a little bit about lint, but I want to preface that by saying that a lot of these checks are common between some of these tools. And this is not an invitation to say, hey, you should use all these tools at the same time, but it's merely to give you an idea of what's possible, and then depending on whatever the needs of the project are and so on and so forth, you can decide which of these tools to use if you're not using some of them already. But irrespective of which ones you decide to use, you should definitely use Lint because it is the one with the most Android advice in it from Google directly. So to give some examples, I have this method that's just firing a call intent, starting an activity with a call intent. Looks fine, right? Nothing fundamentally wrong here. Anyone see any problems with this? Well, you know. Okay, so Lint will tell us that you know, you didn't declare the runtime permission, for example, which from that code it's not obvious that you need a permission because you're just firing an intent, right? But Lint will actually tell you, hey, if you want to do this, you need to have a call phone permission. Here's another example. I'm setting this is an activity subclass, and we're just setting we're setting a layout, and we're getting a button and setting a quick listener. Imagine that the quick listener does something, but that's not the point. So again, this code looks completely fine, but then Lint will say, hey, you made it an image button, it's actually a button. But again, well, think about it from the perspective of you reviewing your coworker's Git. How would you identify this? Unless you're looking at the same time at the XML file as you are with the actual code, right? Continuing on this example, can anyone see something wrong with this code? Second?
Why is it down?
It's because it's not mutated after.
It's not optional?
That's fine. No, it's fine. So there end up being 2 problems. There are actually 2 problems with this code. The first problem, it was kind of a trick question, sorry. But in this particular demo example, the main SDK is 14, but setting the background like this only works on 16 and above because the set background call is there on 16 and above. But again, super hard to tell that just by looking at the code. You would have to use the backward compatible method. The second problem is that the setting the color on the color drawable takes an actual color, not a color ID. And again, that's a very common case that a lot of us fall into, and Lint will warn us about these. Lint also has a bunch of additional checks, as you know, to highlight a few wrong threads. So if we're annotating, if we get into the practice of annotating our code with UI thread for code that will run on UI thread or worker thread for background work, it'll warn us when we are doing work on a wrong thread. Long log tag. So a lot of us still log things using log.e, log.b, and so on and so forth. should try to move away from that and use something like Timber or one of the other tools so that we don't leak in production, sensitive information in production. But needless to say, a lot of people, when they do this, they set the tag to be the class name, but they don't realize that Android truncates it after 23 characters. So again, Lint will tell you about this. This one was super interesting, actually. So this was probably one of the checks added for room. If you actually declare a column as a string, intending to make it text, SQLite actually detects it as a numeric value, which is like super very subtle. And it treats it as a numeric value, but it stores the value as text because it doesn't know how to convert it to a number, unless you get in these really weird cases where it does convert it to a number, but then it overflows, and so it sends it to infinity. And you're like, how did infinity get into text in my database? And so that's why Lint will save you a lot of problems. You can imagine how much time this saved you by identifying this early instead of like, I have a bug in production and I'm trying to work backwards of where this might come. And many more. And of course, the very sad, this linear layout view is useless, no children, no background, no ID. So sad. Another tool I want to talk about, which is really good for identifying problems, but mainly in Java code, actually, is error code. So error code is a tool made by Google for checking Java code. So let's jump into some examples. Here's one example where we're trying to sort this collection, but we're actually returning the original unsorted collection accidentally. And so, it tells us collection is modified in place, but the result is not used, which again might be super hard to catch during code. Here's another example. I have this method that I'm trying to get a simple date formatter so that I can print something out. So it returns your month date, and I'm probably going to use that to print something. Error code will warn me that you probably meant lowercase wise, not uppercase wise, because uppercase wise refers to the first day of the last week of the year. So for people that want to say like on week 52, Monday or Saturday or Sunday or whatever was in 2017, not 2018 or whatever. So here you just want lowercase y's. Again, how would any of us catch this in code review? Very unlikely, right? Here's another example. Here's a find Waldo method that takes in a set of values and it looks for the Waldo with ID 1. But the sad thing is, this method will never find Waldo because one is an int, and this method is checking values of long, so this gets boxed to an integer, not to a long value, so you can't actually find it. So again, very, very hard to catch otherwise by during code review. Here's another example. I have a volatile variable, and I'm decrementing the volatile variable, which again looks fine, but then error code will warn me that decrementing a volatile variable is non-atomic, which could have thread safety implications. Here's another case. I have a switch statement with a bunch of stuff and I'm returning a string at the end. Again, it looks completely fine, but then it will tell me like, hey, did you really mean, did you miss a break after here? Or did you really mean it? And if you mean it, like you should say you meant it by adding a fall-through comment, because otherwise people don't know. Here's another example. I have this class, this class, and it has an assassin in it. Okay, and then I subclass the class, and I have the same assassin in it. There's nothing fundamentally wrong with this code, but it's bad practice, right? Like the assassin should not live both in the parent class and in the subclass. It should live in one or the other, right? And error code will tell you this. Again, it's super hard to catch in review, especially if the modification only happens to the subclass, not to the superclass, for example. Error code has a bunch of additional checks. To highlight some missing override. Which one gets on my nerves actually when someone overrides a method, but they don't mark it as override, so you don't actually know, so you rename the method and then things break suddenly. And that's why in Kotlin you actually have to put the override keyword. Class can be static, so when you have nested classes, if it's not accessing state from the wrapper class, it'll tell you maybe you should make it static. And again, this is why by default nested classes in Kotlin are static unless you declare them otherwise. Remove unused imports. Self-assignment. These are again like subtle bugs that might happen that we might miss, but error code will catch. It also does some security and performance checks. If you're using some of the crypto libraries, or if you're using the make securely, it'll tell you. Fragment injection. If you're using preference fragment and you don't override a particular method, someone can inject code into your app. Again, error code will tell you. If you're using Dagger and you're injecting a implementation for an interface, instead of using app providers, if you use app binds, it's a lot more efficient. So error code will tell you also. One last tool I want to talk about is Infer. Infer is a tool by Facebook that does a bunch of stuff, including some null checking. So let's take an example. So here I have this method that may or may not return a shadow. So it calls this method that either returns true or false. If it's true, it returns a shadow, otherwise it won't. And then I call this code. I say I get the shadow and I call it shadow. So Infer will warn me that, hey, this is a potential null reference, right? Because I could actually get a null pointer exception by running this code if I run it with something like, if in this first case it returns null, when I call the second method, shadow will throw a null pointer exception. And notice actually the other interesting thing about this is notice that I'm not annotating the methods here. It detects it even without annotation of the methods, which is pretty cool. It has a bunch of additional checks, context leaks, so memory leaks with the context, resource leaks, where you open an input stream, for example, and you forget to close it, unsafeguarded by access or shared state that you're supposed to lock a variable before modifying or something, if you forget, it warns you. I should also point out, Infer actually works has checks on C, C++ as well, and actually Objective-C as well. There are a bunch of other tools out there, so just to mention a few, but KT-lint is one that I want to point out because it's actually good for checking stylistic things in Kotlin code, but there are a bunch of others as well that many of you may have used at some point in time.
All right, so now we've looked into static analysis, how it can help you to maintain your code quality, your code style, and avoid possible bad practices or possible bugs as well. So that part is covered and we fix some of these bugs. So now we need to actually make sure our app and logic actually works. And we do that by testing. And when we talk about testing, there are mainly two types of testing we talk about. There's unit testing, where you take your methods or units of code, and then you run tests against them and make sure for a certain input they behave correctly and so on. And that's great. But when you're talking about an app, you need to make sure that the whole feature or flow is working correctly. And for that, you need unit tests. UI tests. And when you're talking UI tests, you have something like in Android, you have Espresso and Espresso Test Recorder, which is great. You just run the app, click a few things, assert them, perfect, done. But you run into issues when you're dealing with network calls. So if you're just testing things like login and so on, you have issues that, okay, now it works, but if your server is down, your network has issues, your test will fail even though it should be successful. So if we actually do write our Espresso test to hit our read APIs, one, they're flaky or unreliable because there are a lot of external factors that might cause our test to fail, while our code is actually correct, and that's not the reason. Also, you cannot really test some edge cases or very hard to reproduce scenarios, or even things like your server throwing a 400 or a 500 HTTP error. And last thing is, if let's take Careem for an example. We have booking. So if you want to create a booking as a customer and we want to test this flow, well, one, that means dispatching a real-life captain to pick up the customer, which in this case is just a test. That means wasting the captain's time. That also means that our test needs to pay some money. That means we need to either the developer will have to pay some money for their test, or the organization will need to pay some money at least to compensate the captain for wasting their time. So that is not really how this should really happen. So what other options do we have to make sure that our tests can test network interactions in a stable way that is not crazy? So other way is using a mock interface. So those that are familiar with, let's say, retrofit works by defining your API as an interface. So what we can do is in our test, instead of providing the real retrofit implementation of the interface, we can make a class that implements the interface according to certain inputs, return certain results or values. So that is extremely reliable because for the exact same input, it should always have the exact same output, which is nice. But then you run into other issues. One, that means more coding needs to be done to handle, for this input you need to return this result, and so on. More code means, more coding means more code to maintain. And if you have a lot of code and custom logic, that means you basically need to write tests to test your mock interface in order to test your, to provide a mock interface to test your UI test, and that's just getting crazier and crazier. So what other options do we have? We can change that and go implement a mock web server. So for those not familiar with the concept of a mock web server, it's simply a mapping. So it's a web server that runs, and it simply has mapping. If we hit this URL, just provide this response. So all we need to do is build this mapping. And if you're using HTTP, this server basically can run within the same app as well, which is perfect, so you don't even have network issues and where to host and so on. So that's great, but it's reliable, and it's not really any coding because the tools are ready, but you still have two issues, which is you need to maintain this mapping between the request and the response, and also you need to spend a lot of time preparing to collect all of the data for your tests, which is also quite cumbersome or annoying, frankly. So what have we done at Careem in order to make this easier to implement a mock web server? We implemented an interceptor, and this interceptor, again, for those not familiar, is basically just a layer we add between our API calls and actually hitting the server. What it does is it listens to our requests and waits for their responses to come back. And then from this request and response, we can simply build a model that has all the data we'd like, URL, headers, body, and so on. And then we just take this data and dump it to either a file or an external server, and now we have our request and response. So that's pretty easy. So we made the collection of data much easier than copy-pasting manually from logs or whatever. So that's great. Now, what do we do with these dumped requests? Do we still need to manually do the mapping? Not really. What we did is we saved them as a Postman collection. And Postman is a very nice simple tool, which is basically allows you to test API calls, to modify them, and so on. So the reason we used Postman as a Postman collection as a format is one, it has a nice graphical interface, and it allows you to easily edit the responses. So in case you want to test edge cases, all you need to do is open the collection, you can easily search through the requests and modify the response to test your edge scenarios. And it also supports placeholders for host, path, or headers, and so on. So you can test also even more different scenarios of the same data sets. Okay, great. Now we have our data as a Postman collection. Still, we didn't really talk about how we consume it. Do we still need to copy paste it in the end? And for that, let's talk about a simple scenario and how we test it. So let's say we want to test login. So the first time we want to write the test, all we do is we enable our interceptor, we run the espresso test recorder, and we make a test. So we simply enter an email, password, and before click on the login. Perfectly fine. And then what we do is for future runs, we update our URL or host from our real server to our mock server and mount the collection. So by mounting, it's a very simple thing. We simply just grab the collection name, load the file. A file can have different collection. We grab the collection with this name, and that's pretty much it. What we do then is we have a mock server from mock HTTP. And with the mock server from mock HTTP, simply is just, it listens to all the requests that it receives. So all we do is whenever we receive a request, we basically filter our collection and we try to match the request we received with the ones we have in our collection. If we find one, great, we return the response. So that's pretty much, so the mapping is done for us. And if we don't, we just simply return a 404. So the URL doesn't exist, we probably didn't record it, or probably our code has our own URL mapping. Okay, so that's pretty nice and perfect. So this way, we simplify the way of collecting the data for our mobile server. We remove the need to do manual mapping between URLs, and it's pretty much just record once and update your collection done. That's pretty great. Now, UI tests don't only test your functionality, but you also we would like to use it to make sure our UI actually looks as we designed it. So how can we do that? So what we've done is the same test from earlier. We added a helper method that all it does is take a screenshot, and we can pass to this screenshot different parameters like which test we're doing, which scenario of the test, what step of the scenario we're testing, and different configuration like language, screen size, device, and so on, RTL or LTR, and so on. So, great, we collected these screenshots. What do we do with them? We simply upload them to our server. So in our case, at Careem, we upload them through Firebase to our server, and then we tag them with a different configuration, so they're easy to search through for their name. And then we run image tagging. There are a lot of tools for that to compare them. And then in case we find any difference, or we have new screenshot, we just tag them or add a property for them that, oh, these screenshots need manual verification. So let's say the first time our baseline test, we had the screen. After some modifications and we push some code, the UI test ran again. Now we have this. Other people might not be able to tell the difference, but using an image tagging tool, it just simply finds that, oh, we changed the margins or paddings of the button, and now we need to confirm manually whether this is an intended change, or oops, we screwed up, we need to fix something before we send the load. So that's pretty nice. So one very cool thing about this process that we follow also is that it allows us to make UI testing cross-platform much easier, because what we can do is all the collections that we've got, the customer collections, it's basically the same data we will run whether we're running it against Android, iOS, or web. So the data is already there. If someone records it, everyone has it. Perfect. You can also, instead of using an OKHTTP server, we have also a Python server that does the exact same thing. And this way, iOS can hit that instead of hitting OKHTTP. And last thing, you can also share the same logic you have for sharing or uploading screenshots and editing them. So we reduce the amount of work a lot, and this allows us to easily run unit tests. They're basically a tiny bit longer than manual regression, and you have it then automated until you do a feature change in your UI.
I want to talk a little bit about hidden changes. Hidden changes are these changes that they don't show up in your app, like you can't tell that they're there when you look at it, but in reality their impact could be pretty big if you don't actually identify them early enough. One such case is permissions, for example, in Android. So let's say, for example, that using AAPT, which is built into Android, I can actually, at the command line, just write a command to say, give me the permissions this APK has. We see this APK has a set of 5 permissions, which is great. And I can save this to a file. Let's say in this case, I'll save it to a file called before, so that after someone commits a new code, I can compare it and see if anything changes. So let's say, for example, I added InstaHook as a dependency now. And then, so now, looks fine, but then I run this again, I save it to after, and I dip it, and then, uh-oh, we have 3 new permissions. Like, where did these come from, right? So again, like, it's, these kind of changes are super subtle, and if you notice them early, it's easy to react to them early. Because then you can say, their documentation tells you, for example, that you can use the manifest metric to actually ignore some of the permissions, or you can decide, I'll enable this only for a certain flavor and not for release, and so on and so forth, because I'll break my upgrades otherwise, and so on and so forth. So the implications could be very wide, but you don't actually see this in a diff, right? So that's one example. Another example is a method count. So for people still trying to stay under the single bets limit, like this is really important, So for example, we can use, there's a keepsake label plugin, and there are probably many others that we can just add to our code to figure out when, what the method count is. So we see in this case, like this particular app that I'm testing has 80% of the method count used, but it's still single dex. And then it generates also a nice HTML web page and chart so that you can actually mouse over and figure all this out. Also, this is built into Android Studio, but it's kind of nice when you're actually on your CI server, you get this. So again, I add the dependency on new library, and then I run it again, and now 69,802, which takes me from a single dex application to a multi-dex application, which of course can have a lot of implications on performance and so on and so forth. And it also outputs a CSV file, so just one file with 3 values: the method count, the field count, and the classes count. So it's very easy to just diff the two, subtract and add them, and figure out what the delta change is. And in this case, one last one is APK size. So for example, let's say I'm working on a new feature, I have an image, and then I notice that the APK size suddenly increases by 5 megs. That probably means that I didn't do image compression on the images properly, or something is wrong with the image that I'm using, because one single image should not increase the APK size by 5 megs.
So far it's all great, but what else can we do with our CI server? What other things we can discover or do with it? So we can, whenever we have a new build, we can automatically upload it to an S3 bucket, for instance, for return distribution to your QA, to do manual regression if needed, or you can automatically upload your builds to Google Play, alpha or beta channels, or even production as a set release date. Or you can even do a post on Slack about that you have a new build, and you can say, from the commit messages, you can say what are the differences. So these all sound also maybe some like quite complicated. You need to build custom scripts for them and so on. But there are a lot of tools that can help with that. So if we talk, take for example, Fastlane for instance. So Fastlane is simply a tool that allows you to make lanes, and each lane will have, let's say you want a lane for nightly builds, you want a lane for release builds, and so on. And it's very simple to integrate. All you need is different configuration files for your different services, like S3 or Slack and so on. And it's as simple as you define your lane. You say you want to make a debug build. You want to upload it to S3. Of course, you already made the configuration at the start for your bucket, API tokens, and so on. And then you want to post on Slack that this is a new version and post it to the QA channel. If you want to do something else, and let's say send an actual release, you can make a release lane and make it a release build. And using Sublime, you can upload it to Google Play after configuring all the needed stuff. So it's quite straightforward, simple, and it makes your life much easier than QA. Can you send me the new build? And you need to stash your changes, compile it, make the APK, upload it, and it's awful. Yeah. So, in addition to that, you can check your code coverage. Because after you make sure there are no new bugs, everything is according to the standards, you need to make sure that new code you're introducing is actually tested. And for that, you can use something like Jacoco for code coverage. It's a very nice tool. It basically allows you to know what's your test code coverage for per class, or which branches are covered, or even you can, because it generates an HTML report, basically you can dive deeper into seeing in your class which method has how much covered and which branches. And you can go to the file itself and see which lines are basically covered and which ones are missed or not tested. There's also another pretty nice tool, and like this screenshot is from RX2, RX2, GitHub. It's called CodeCop, and it gives you a very nice representation of your classes, which classes have increased their coverage, which ones reduced, and a full report with a lot of details, and so on.
So to wrap up and tie all of this up, there are really two big questions to ask. where do we do this work? Should this work be done on the developer's machine or on the CI machine somewhere on some server? Another question to ask is when? Do we do things at compile time, anytime that the engineer compiles the code? Or do we do it when they open a pull request? Or when the actual code is actually committed to the code base? Or maybe sometime nightly? And the answer to this is, there's no right answer, but the answer is it depends. Because it depends on many factors, like how long does it take to run these particular steps. So something like, let's say for example, something like error prone, if it's adding 10 seconds to your build, it might be worth that the engineer adds 10 seconds to their build all the time in order to catch these kinds of issues earlier on. Whereas something like linked, if it's going to take 30, 40 seconds, that's too much to do. So maybe you say, you know what, at the time of the pull request, I'll check it then. For some things like UI tests that might take hours, you probably want to do this on a nightly basis. And then be able to figure out that, oh, this test broke, and this is the commit that's most likely to have broken.
Can we do it like on a feature branch or something?
Yes, so
this is like gonna be the best answer.
Yeah, I mean, so definitely. So some people also choose doing it on feature bench, running all the tests and making sure everything is good before merging the feature bench back into master.
Before doing the pull request.
Before?
Doing the pull request.
Or before doing the pull request, yeah. Again, many strategies, whatever works best for you and your team. A couple of gotchas, flaky tests. Don't sleep in your tests, please. Tool version updates. So this is particularly relevant when you're using something self-hosted like Jenkins. And if you update the version of the build tools, and it doesn't, you have to actually go and update the box to actually have that version of the build tools. Similarly, if the testing environment is unstable, or the CI environment is unstable, then developers are complaining that my code is not compiling properly, even though it works on my machine. And then crashing tests, that's another thing. For the last one, actually, Google has provided this test orchestrator so that for instrumentation tests specifically, instead of one instance of instrumentation under which the tests run, we can actually run each test under instance of instrumentation so that if something crashes in one test, it doesn't crash all the tests. So in summary, invest in improving your build times because this is an investment that pays off across every developer on your team. You'll find a lot of good talks about this, and there are a lot of more things like modularizing your code, things like potentially setting up a shared repository, a shared machine that actually, so that you can say, hey, this particular model hasn't changed, so let's actually get the code from the pre-compiled code from the coworker's machine, and so on and so forth. A lot of really cool things you can do here. Any investment you do in build time pays off many-fold because think of how many times on a day-to-day basis we end up compiling our code. Set up static analysis tools. They're cheap and easy to set up and free. They're actually free to set up if you decide the time that they take. And they can continue paying off over time, finding bugs like the ones we talked about at the beginning that are super hard to identify otherwise. Optimize for code quality and stability. And most of all, automate other things. And if you do all of this, you'll live in a happy, blissful world. That's it. Thank you.
So, any question, guys? Yeah. I want to know about the testing. I was interested with all these efforts you have done testing for publishing the application. Did you ever miss a thing that was discovered later by the user, for example? So I can see the efforts in the testing part is huge.
So of course we have a lot of scenarios that we expect will happen. And this is how manual testing or manual regression starts with. These are the expected scenarios and we run against them. But then whenever users or other colleagues find different scenarios, that means these are more tests that we need to write. So we cannot think of all possible scenarios. We can think of a big portion, maybe 80, 90%. But the last 10%, someone will always face them. And if they report it to us, that will help us to automate it and make sure that it doesn't happen again due to some code changes.
And just to add to that also, if we actually get into the habit of structuring our code properly, then it becomes easy to form a habit that when a bug is reported to us, that we actually say, okay, let me write a test that proves that this bug happens. Now let me fix the bug, and hey, the test now passes. Therefore, if someone breaks it in the future, the test will fail, and then we don't end up making the same mistake again.
So to add up to the testing thing, so the question is, if you, for example, you upload your build to the App Store, and then they reject it because there's a bug. So if the bug is, for example, small, can the developers, do you send it back to the developers to do it, or can you do it yourself and just fix it? That's it. Just upload it.
So whenever we face any bug that you're talking, we send it to Google Play or yeah, okay. So if we do send it and it's rejected for some reason, or even if we do release it and then we find out a crash, then that probably requires a hotfix. So what we do is, if we know who's the person most familiar with the topic or work on a certain part, then we can tell them we need to get this fixed. They schedule it according to the criticality of it. It's scheduled, it's fixed, and we upload a new build. And pretty much that issue pretty much needs to have a test to make sure it doesn't happen again in the future.
Yeah, so by you mean the developers or the people who try to, the one who test the app?
So, so you're talking, so usually the developers themselves, we test our own apps, we write our own tests and automation tests for them, and then additionally we send it to QA for manual regression. If they do report issues, then we do fix it and write tests for that. So whenever we add code, we add tests to validate this code.
Any other question?
I had a query regarding, for example, like even though how many tests you do, but like for example, you have a staging environment and a production environment. Like you're always doing all the tests on the staging. You can never get the same exact environment that you get on the production because you have the consumer data and everything. So do you guys do anything like differently to have like more coverage on the staging environment when you run all of these tests?
So from an app perspective, pretty much most of the time we shouldn't really care about which backend we're hitting. We need to cover as many cases. So the differences in terms of staging versus production usually come from a backend. And for that we have separate pipelines for API validations, unit testing, stability, regressions, and other types of tests that we run on our backend. And we try to make sure that adheres to the process. But from a front-end perspective, we usually don't do anything that, oh, if it's production, we need to confirm this. Because one of the main things that might be different between production and staging is production has more random data, so it might be slower to load and so on. So for that, you can actually run your tests against 2G network, or basically make your calls much slower, or even fail them. So you need to make sure that you handle failures. And if you attended the morning session, which is what they call the next 1 billion users, you need to make sure that you always build for offline and online, and not just online, and if an exception happens and you're offline, then do this. No, you need to make sure that you accommodate for both.
Assalamu alaikum. My question is not regarding Android basically, because it's not regarding the public facing app, just like Careem. But my question is regarding internal tools, for example. We build internal tools and we have very limited time to build it. And this testing, setting up analysis, static analysis, and unit testing and all that requires a lot of efforts. So like doubles the time of implementation. So how can we reduce some of these steps and just implement some of them which are very critical? What are those main points that in internal tools we can just implement them?
So some of these are actually, even though they might look complicated to actually set up, they're actually pretty simple in many cases, especially to set up on a developer's machine. So the lowest hanging fruit would be to set it up on a developer's machine instead of actually setting it up on an actual CI server for things like internal tools. So in your build.gradle, you usually have to add 2 or 3 lines that you just put, and then by default it just starts checking your code after that when you run a particular command, for example. So that's the way error-prone works. That's the way lint works as well, and even checks out, I think, similarly. So a lot of these tools, the more complicated part is actually setting it up when it comes to having a server, and then how do you, not so much how do you run it, but how do you actually take the results from these tools and actually connect them with the code base, with the diff, so that you can see, oh, this line, I'm talking about this line here when I say that a space is missing, for example, or whatnot. So that's the part that actually really takes a little bit more time to set up. So, but doing it on developers' machines actually.
Actually, how do you test this business logics, and how do you test device compatibility to the lower end and these things? Like you have a promotion coming up, that one, and how do you test that promotion?
Okay, so this is broken into 2 parts. So business logic should be pretty much unit testable. So once you have pretty good unit testing for your business logic, you should feel confident with that. For the parts where you're dealing with lower-end devices versus high-end devices, then you can start testing where the emulator that you launch to run your Espresso test on, you can have it with different configurations. You can give it less RAM, you can give it slower network, you can give it less memory, and so on. And also the app, you can make sure to run the same UI test with English, Arabic, Urdu, French, Turkish, and all the other languages that your app supports as well. So,
but in emulators, you don't have many apps running in the background. But in user device, you are having many apps. Like ESM consume all the memory.
yeah. For that, you can enable don't keep activities, which is a developer option. So that will simulate the worst kind of memory management possible, where we don't have memory, and every time you open an activity, the previous one is killed. So you can simulate that using that option. And again, if you launch the emulator with a very low RAM, it more or less behaves like if you have a lot of apps open in the background.
And in addition, you can actually, on a lot of the cloud testing providers, Firebase and Amazon AWS and so on, you can actually choose between running an emulator and running an actual device. So they have a list of actual devices. You can say, hey, I want to run this on a Samsung Galaxy S2, which is like 100 years old now, and you can make sure that the app still works. Okay.
My question is on when some of the NFRs which are not even business related, something like adherence to regulatory compliances or policies and all, it is like whether you do it as part of your unit testing or you do it at a later stage in SAT or in performance testing and other cases.
May you repeat?
Some of the testing like regulatory adherences, regulatory framework which the government is by these are actually not neither business, these are not technical and actually it is ongoing. When you develop the software, you don't know actually what are the regulatory requirements. All of a sudden, the government issues that regulatory notification actually the business has to be like this. So do you do it at the end of the testing phase, or you do it at the early stage and you do it to the coding phase?
So I guess this is more from a business perspective is how they suggest. So usually as engineering, what we work with is product comes to us with requirements and we look at all the engineering aspects for it. But usually we expect product or business to have already run through all the legal or regulatory requirements before they come to us. Or even if, let's say, they don't do it before and we do release, we make sure pretty much most of our stuff are behind toggles. So let's say government says, oh, this cannot happen, we can switch it off until we fix the issue with the regulations, and then we switch it back on in the country effectively.
Thank you.
I'm curious to know how to test analytics. For example, when you click on a button, you should send an event to analytics. So when you test, I can test it because I send a trigger event in presentation layer, send the event in integration layer, and also for UI test, it's UI and analytics is not UI. So how to test analytics?
Okay, so usually analytics pretty much is, or most of the time, it's a really provided SDK that you work with. So what you need to do in order to test it is to make sure not to use the SDK directly, but wrap it behind an interface or a wrapping task. This way, in your unit tests or UI tests, whichever, you can provide your own mocked analytics interface or implementation, and then you can listen to and make sure these calls. Now, if their SDK is failing, that's a bigger problem. You need to find a better analytics tool.
It also saves you time, right? Think about it today, because a lot of times product has different requirements that change. So today they're like, oh, let's use Mixpanel, and then tomorrow they're like, no, let's use Google Analytics, and so on. We don't want to have to rewrite go back and rewrite all the call sites, right?
Hi, my question is for Ahmed. Ahmed, you're at University of works for popular companies like Facebook, Twitter, and Apple. You're a very successful developer. My question is that developers on these companies, are they really pay enough attention to testing? I mean, they do really do test-driven development, or they at least write regression testing, unit testing, automated UI testing. Is it really a company culture there?
Yes, absolutely. Absolutely. Because in these companies, a lot of the things, a bug there might cost millions of dollars. If you have a bug, for example, and a button is not clicking, you may lose millions of dollars of ad revenue just because of that one bug. So everything actually, I would say test-driven development, that's only some companies have that, but definitely a very strong culture of testing, making sure that any commit that goes in the code base has passed all the unit tests, all the instrumentation tests, and so on and so forth before actually running it.
Thank you.
Any questions? I'll just ask mine. So when exactly you write UI and unit tests? So for example, developer has to submit the test case along with the pull request, or you guys just let the code go with this pull request and there will be later a session or time and you will do the unit testing of that particular unit?
So when we're talking unit tests, pretty much any code you check and or make a pull request with, it needs to have a unit test. Let's say in some extreme cases you're working on a big feature and it might be hard to even unit test, then usually you do pull requests against a separate branch, and then before that branch is merged, that branch needs to be unit tested. So you need to make sure that your develop branch or your latest branch or master should have everything fully tested. And when you're talking about UI tests, that really depends on that ticket you're working on. So some things are behind the scenes, so the current unit test will validate it, and some stuff are actually UI where you need to update this or write completely new tests. So that is also expected with the new code. But then you have unit tests UI tests that might be done separately, alone, which test basically integration across multiple features or stories or pull requests altogether. And these can be done separately, either by also engineering, or it can be by QA team and so on.